So this video covers logs in TMUA. The things that they expect you to know are this thing: if log to base a b equals c, therefore that's equivalent to a to the power c is equal to b. So that's just basic log definitions. Expects you to know the addition rule, where you by log of a plus log of b is log of ab. And it also, if it's a subtraction, then of course it's a divide. The power rule, log to base or log of a to the power n, the n gets brought to the front like this. Also useful to recognize immediately that this thing is just negative log a, because this is a to the power minus 1, the minus 1 goes to the front, and there it is. Also useful is the change of base law, which I'm not actually going to do in this video at any point, but will be done in a different video, which will also have some logs in it about TMUA. So look out for that in the future, but I won't use this straight away. It is useful to know this though. And also, of course, we can't put a negative into a log and get a real answer. So A, B here are both positive. So yeah, that's useful to know because we'll get multiple answers at some point and we have to disregard them because they're negative. Now, I don't usually do this, but let's go through some things that are not rules, that are basically the only way to stuff these questions up massively. This is a rule, this is a rule, this is not. Lots of people want to deal with log of a plus b in a bracket and pretend it's like multiplying them together, essentially doing this just wrong, or even just multiplying two logs together like this. This is all wrong. You can't do anything really with this when you see it. So don't be tempted to, so please don't do any of that. This is also obviously a correct rule, this is not. So if they write log of a bracket squared, that is not a to the power 2, which you can then bring to the front. That's log of a all squared. And again, you can't really do anything with this, so please don't do that. And finally, lots of people look at this and immediately disregard it because they go, oh, logs can't be negative, no solutions. Of course they can be. We know from the definition that this means a to the power minus 3 is b. Now you can't, again, I'll say it again, you can't put a negative in a log. That is different to logs can't be negative. When people do this, they often read this as if they're reading x squared equals minus 3 and immediately disregard it. No, no, no. Logs can be negative, you can't put a negative in a log. Let's make sure we get that right. Anyway, let's do some questions then. So the question numbers from the papers they're in should be up here. This one first just needs to follow some log laws here. So, well, okay, all the logs have base 10 in them. So let's take log to base 10, or except for this one, I guess, and this one. But let's take log to base 10 on both sides. That seems like a sensible thing to do, because then we can start using some log laws, can't we? So, okay, well, here, and again, logs are always tied in with exponentials as well, I guess, aren't they? So remember your exponential laws here. If all these things are to the power x, you can just factorize that x out, because of course when you do this thing here, that's a to the power x, and then b, and then 2 times x makes 2x, and then 3 times x makes 3x. So this is all fine, but now we can use the power law for logs to move this x all the way down to the front, and then of course we can just divide by what's left over, and we end up with the answer almost immediately. So just following both our exponential and our log laws there will get us the answer quite quickly. Another question which is very similar. Again, following our laws, we have that these things are all multiplying, right? So we can say this is log of a plus log of b squared plus log of c equals 7. But log of b squared, we can move the 2 to the front, and we can get this. So I've used 2 log laws to achieve that. And I'll do the same thing for this second one here. It turns out actually you don't need the third equation at all for this question, which is really interesting. But anyway, all I have to do here, I think, is if I just double up the first equation to get this. So all I've done there is double up the first equation, and then just do the first, take away the second. I end up with this. And now divide by 3. And again, this is just recognizing how logs work. Log to base what of b equals 1. Well, if you raised everything to whatever this base is, you'd have you'd have something to the power 1 is equal to b, but of course that's just got to be b. So log to base b of b is 1, so the base is going to be b. So again, a question that you can achieve quite quickly as long as you really bear in mind your log laws immediately. Admittedly, this trick is not easy to spot of just doubling this and you immediately kind of get to the answer. But yeah, bearing in mind our log laws is going to work here. Some more normal questions, I guess, that you see more typically for the next 3 questions. Those first 2 were kind of just tricks that you just wanted to be trying to find as long as you followed log laws. These ones are much more typical questions that actually require proper work, I think, or regardless of what you do to them. It's possible here to just get rid of this log by saying this is 3 to the power 1, but I don't know how much it achieves. I think it is possible to do it like this, but I think the better thing is to immediately follow log laws again. Now, this is one of our common mistakes, wasn't it? So we're not going to do anything to this because we can't. But this one we can say is log to base 3 of x plus log to base 3 of y squared, and then the squared can move out to the front. And then here I can rearrange this, I think, or I can rearrange this one for log to base 3 of y. And then I can shove that one into there. And I end up with an equation just in terms of x, which is good because I'm looking to solve for x. I could have rearranged for y and got y's, but then I'd have to put them back in for x's. And now this is something we want to recognize. What you want to do is multiply everything by log to base 3 of x. This is pointless, of course. I don't know why that's there. Multiply everything by log to base 3 of x, and you get this squared plus 2, or this is going to be a minus 6, isn't it? And then this is there. And this is just a quadratic, right? So you can make a substitution if you want to, or you can just be very comfortable putting a log to base 3 of x in some brackets. Like this times this is log to base 3 of x squared, minus 3 of them, plus 2 of them make minus 1 of them, and then minus 6. So of course we either have that this thing is equal to 3, because that would make 3 minus 3 equal to 0, or this thing is equal to minus 2. Again, don't just disregard this. This means that x is equal to 3 to the power minus 2. This means x is equal to 3 to the power 3, which is 27. That's of course a ninth. Add them together and we get 27 and a ninth. Okay, so just following our log laws and making sure that we don't make up a log law when we see something like this. And then of course, when you've got a kind of a fake quadratic to do, dealing with it as necessary. Another one which is very similar, we've got a quadratic with some log laws in here. So this one here, this is x to the power minus 1, bring the minus 1 out to the front, and we get this. But of course when you square a negative, that's the same as squaring a positive, right? Because the negatives just square out and cancel with each other. So I can just do that. And now, if you feel more comfortable, this is probably when you want to make a substitution. Y equals log to base 2 of x squared. If you square both sides, you get this, which is why I can replace that with a y squared, that with a y. 2 to the power 6 is 64, just good to know that straight away. And this factorizes, which means either y is minus 16 or y is 4. Y you defined to be this. This is when you can disregard a negative solution because you've got something squared. So you can disregard this because something squared can't be negative 16. But here we can square root both sides to get plus or minus 2. Just be very careful. Which means log to base 2 of x is either 2 or negative 2. Again, do not disregard this because logs can be negative. You just can't put a negative in a log. So we've got 2 to the power minus 2 is x or 2 to the power 2 is x, which of course gives solutions of 4 1/4. The difference between them is 15 over 4 if you do the maths. One more question about this. So here's a really interesting question, possibly my favorite question ever asked in TMUA. I've forgotten to put the question number, but I know it because it's my favorite question. It's 2021, paper 1, question 20. So just in case you want to look this question up. So what we want to do here is, again, follow log laws. Don't make any up, just follow them. So let's move this 2 out to the front. I know every single time we've done this, we've actually done it the other way. But let's put this 2 up down to the top here. And then let's combine these two by doing this one times this one, right? And now we've got log of something equals log of something. Now you can just cancel the logs out. You cannot cancel logs when it's looking like this, when there's 3 of them. But you can do it when you've just got a log on either side and everything is collected like this. So now I can say this thing is equal to this thing without the logs. Good. Just do some algebra. Eventually you get to here. And you might recognize this in regular A-level maths as something you can complete the square on for both x and y separately, and you end up with this, completing the square properly. Move the other things over, and we recognize a circle, radius 6, center minus 5, 1, which is really cool, which we can sketch down. There it is. Circle radius 6, center minus 5, 1. Cool. Well, of course, we know the circumference, or it's asking for us the length of the curve, which is this length of this curve. But we know the length of this curve, right? Because it's just a circle, just the circumference of a circle. Radius 6 means it's going to be 2 pi r, of course. Circumference, 2 pi r. 2 times pi times 6 is 12 pi. So, okay, sure, the answer is 12 pi, except, how many times I've said in this video, logs can be negative, but the inputs can't be. So here, x minus y has to be positive. 2 minus 2x has to be positive, y plus 5 has to be positive. And of course we can work out what each of those mean, right? This means that x has to be less than 1, rearranging. This means y has to be greater than minus 5. So when we go back to our picture, we can actually region off places that don't obey this, right? So draw all of these lines, that's x equals y, this is x equals 1. Notice how this is minus 5, the radius is 6, so it just touches the line x equals 1 here, and y equals minus 5, again, from 1 going 6 downwards, because the radius is 6, you get exactly to minus 5, so it goes across like this. And so we need to be x greater than y. So we need to be below the diagonal, we need to be to the left of the vertical, and we need to be above the horizontal here. So we can be in here. But again, notice how this point was exactly horizontal from this one and exactly down from this one. So we have a quarter of the circle. But of course, a quarter of the full circumference 12 pi is just 3 pi, and that'll be our answer. So always remembering our log laws and how we can manipulate them. Don't cancel logs that look like this. Only cancel logs when you've got log of something equals log of something else. Remembering that you can't input negatives into logs, and that would have got you the whole answer. This was the last question on that paper, so therefore apparently the most difficult one, also my favorite ever one. I think my favorite question ever asked in TMUA. But anyway, thank you so much for watching.